Hello, and welcome to our lab on simple machines. Your essential question for this week is, how do simple machines make work easier? Last week, you investigated how different sole textures of shoes affect how easily a shoe will move across the floor. You also examined how adding weight to the shoe affects its movement. What you learned helped you understand factors that affect friction between surfaces. This week, your challenge is to go on a scavenger hunt around your home to find a variety of simple machines and claim bingo. So here's some materials. They are optional. We're going to get to those a little bit later. These are materials that you can use to put together a simple machine. Okay, so what I'd like to do is, before we get to the activity of bingo, I want to jump down here to when they define what simple machines are. Okay, so we're going to talk about this part, same work, different force. We're going to talk about this in class, so I'm not going to read this, but I do want to go over the type of simple machines, and I encourage you to do the Edpuzzle because the Edpuzzle goes over these as well. Okay, essentially you have 6 different types of simple machines. You have an inclined plane. An inclined plane is a simple machine that is straight, slanted surface. A ramp is an inclined plane. Rolling a piano along a ramp requires smaller input force than is needed to lift the piano up the stairs. The same work is done on the piano, just over a longer distance, and so you're easing the effort, okay, that's required to go into it. Screws. The screw is an inclined plane that is wrapped in a spiral around a cylinder. When a screw is turned, a small force is applied over the long distance along the inclined plane of a screw. Meanwhile, the screw applies a large force through the short distance it is pushed. Screws are used most commonly as fasteners. Levers. A lever is a simple machine that has a bar that pivots at a fixed point, called a fulcrum. Levers are used to apply force to a load. Have you ever used a claw end of a hammer to remove a nail from a piece of wood? If so, you're using the hammer as a level. A wheel and axis. Axle. A wheel and axle is a simple machine that consists of 2 circular objects of different sizes. A steering wheel shown is an example of a wheel and an axle. Doorknobs, wrenches, faucets all use a wheel and an axle. Wedges. A wedge is a pair of inclined planes that move. A wedge applies an output force that is greater than your input force, but you apply the input force over a greater distance. So, for example, a knife is a common wedge that can easily cut into a melon and push apart its 2 halves. Other useful wedges include doorstops, plows, axe heads, and zippers. Pulley. A pulley is a simple machine that has a grooved wheel that holds a rope or a cable. A load is attached to one end of the rope and the input force is applied to the other end. When you open window blinds by pulling on a cord, you're using a pulley. And then a compound machine is any machines in the world. Most of the machines in the world are compound machines. It means that they're made of 2 or more simple machines. For example, a can opener. Which is actually 3 machines combined. It consists of a second-class lever, a wheel and axle, and a wedge. When you squeeze the handle, you're making use of the second-class lever. The blade of the can opener acts as a wedge, and it cuts into the can's top. The knob that you turn is a wheel and axle. Okay, now let's go back up here. So that's just an overview of what the 6 types of simple machines are. So what you're going to do here is you're going to do a bingo. Okay. Look around your home and find as many of the simple machines listed on the bingo card as you can. Use a simple machine that you find. Note, use all the simple machines safely and with an adult's supervision. Once you have used a simple machine, circle it on your bingo card. Draw a horizontal or diagonal line through the circled simple machine on your bingo card. So, and again, you guys can just write them, and if you have other ones that you like to do, you can. So we're just getting familiar with the different types of simple machines. So B's are all your levers. So you've got scissors, screwdriver, a bottle can opener, a light switch, a broom, or a rake. I are all your screws, screw or bolt, light bulb and or the receptacle, meaning what you screw the light bulb into, a twist faucet, a bottle or jar lid, a ballpoint pen, and I think what they're meaning is on that screw part right here. Your N is a wheel and axle, a doorknob, an analog clock, the dishwasher rack wheels, a pizza cutter, a door hinge. Your wedge, you've got a knife, a zipper, a door stop, again, a bottle or a can opener, and scissors. So scissors, you see that they can be a lever and a wedge. Inclined plane, stairs, sidewalk ramp, a dustpan, a chisel, a ladder, or a step stool. So in your scientist notebook, create a table like the one below. How simple machines make work seem easier. Write down a simple machine in the B column of your bingo card. Again, if you have one that you found that's different, you can use that. At the simple machines in this column are the levers. So all of your B's are your levers. Decide if the simple machine changed the direction of the force or the distance through which the force was applied, or both. Include observations to support your answer. So really what this is it just wants you to really think about, okay, we have all these simple machines around us. How is it that they're working? How is it that this is making work easier for me? So here's your first column has been done done as an example using a different type of simple machine not on your bingo card. So here is a window blind pulley. So like on the school, I don't know, you may have them at home. I don't think I have them at my house, but the window blind pulley, it changed the direction of the force. So as you're pulling down, the blind's going up. When I pulled down on the cord, the blind went up. So this is the key part of this, is it's really just making you think, and can you write, can you express what is happening on here? Okay, repeat. Oh man. What happened? There we go. Sorry. Repeat step 6 for the remaining bingo letters, representing the other types of simple machines. Check your understanding, and this is a read the additional information, and that's what we had done first. I like doing that first. Okay, so if you want to go, I take this as if you want to go further. Select and make 2 items from the simple machine board on the following page. If you don't have the materials of any of the items on the simple machines choice board, compare the work done with and without 2 simple machines on the bingo card. So just how was the work done? Okay, so for each item you create, name the simple machine and explain how it made work seem easier than doing the task without the machine. So here you have a spoon catapult. That looks kind of fun. And again, you can use different things for this part. The seesaw lifter, big wheels, pulley power. So here are 4 different machines that you can use to make. So try and do 1 or 2 of those. It might be kind of fun. See if you could come up with another one. Okay, and this is, we're going to talk about this in class. So going further, and if you wanted to one of these instead of doing those, that would be fine. Your mystery machine. Think about complex machines in your everyday life that make work easier, such as a wheelbarrow. Identify 2 or 3 simple machines that allow complex machine to operate. Some examples would include a stapler, a wheelbarrow, a bicycle, a hand drill, a mixer, goes on and on and on. Number 2, marvelous machines. Think of 3 tasks that you typically do in your daily life that you could do with or without a simple machine. For example, lifting a box of books. Explain which simple machine you would use to make work easier and why. A Rube Goldberg machine is a contraption, an invention, device, or apparatus that deliberately over-engineered to perform a simple task in a complicated fashion, generally including a chain reaction. The machine is named after American cartoonist and inventor Rube Goldberg. Okay, so next week we're going to be doing a review of our packets, maybe add a little bit more. This is going to be some information, this background that we're going to cover in our synchronous lesson. But that's it for simple machines. Good luck. Let me know Tuesday and Thursday if you guys have any questions. I don't know if that. Ay, ay, ay.